doing right now because this is the notes. So this will be eligible for test and quiz use. So basically, we're going to be combining like terms. Basically, if you see a plus in the middle of your parentheses, basically all that's going to mean to you is the parentheses don't really mean anything. So what I'm going to do is I'm just going to rewrite my terms without having the parentheses there. And then I'm going to go through and look for like terms, and to combine them, I'm going to be done. But when I'm doing this, I still have to be cautious because I still have to pay attention to the signs that are in front of my like terms. So like here, yeah, that's 4 plus 3. Okay, so that's 7. Okay? When we're adding and subtracting, though, I'm not looking to mess with any of the exponents. This isn't like before when we were multiplying and we add the exponents. These, I leave the variable alone. I just mess with the coefficients, the numbers in front. But when I get to my numbers this time, my constant terms, now I got to be careful because a lot of you still think combined like terms means it just goes up in value every time. And that's not necessarily true. Like here, I've got a -5 and a +6. So if I put those together, what do I end up with? 1. Okay? And that's as far as I can go because I can't put my A's together with something that doesn't have A's. They're different.
How'd you get 2? Oh, never mind. I don't have my best.
Oh, okay. I was like, 2? What?
Yeah. Right.
Okay. So anytime, again, that you just see plus, we're basically going to ignore the fact the parentheses are even there because they're not going to do anything for us. But when I get here, here's where I also start to think a little bit. Because we want our answer to be in standard form. And what that means, basically, is we want it from the largest exponent to the least. Because we want to get in that habit, because that helps us when we're looking for a lead coefficient or the degree of the polynomial or something like that. So it offers us some other benefits. So if I want my answer in standard form, largest exponent to least, which term should I be starting with? Yeah, this 4x squared right here, because that's got the biggest exponent on a variable. Yep, and then I also notice I have just a plain old x term, which I can't do much with, so that goes next. And then, yep, I can combine my like terms because I have two just plain old numbers, two constants. 9 and a -7, or 9 minus 7, is 2. So not only do I have to pay attention for like terms, but I also want to pay attention to what degree things are so I can make them go down. Ooh. But when I get to 3, this is going to get a little interesting. Because I start to look and I'm like, okay, and do I actually even really need to rewrite this every time? If I see plus, I can just kind of ignore the parentheses. I could do that. Now this time, when I go to start putting these together, I'm kind of looking and I'm like, okay, I know these are going to go together because they have x, y. I know these are going to go together because they have just plain x. But which ones do I need to start with? Yeah, I need to start with the xy's because if I'm looking at their degree, xy, if I add those up, has a degree of 2. So I'm going to put those first. So if I got 6 and I add 4 more, I have 10xy. Again, don't mess with the exponents, just leave them alone. And after that, whether I use the x's or the y next doesn't matter because they have a degree of 1. It's just x or y. So if I want to do the x's next, since I'm combining, I can. 6 minus 1 is 5. And then I've got the 2 y's left over. So we're always looking to have the largest degree first. So like here it was degree 2, degree 1, degree 1. So those would be interchangeable if I wanted to do that. So if it's adding, it's not really that big of a deal. However, once it turns into subtract, we've got to just go through and distribute the negative to every term in the parentheses that follow it. So here's how this is going to work. This negative, or this minus, distributes to both of those. In other words, it changes the sign that they currently have. So this positive 5a will become minus, or negative 5a. And this positive 1 will become minus, or negative 1. Once I've done the distributing, now it's just like when I was doing the sums up above with the adding. Now I'm just going to combine like terms, but I do have to watch my signs. So for instance, we've got our a's here, 3 and negative 5 would be negative 2. Negative 5 and negative 1, if I put those together, is negative 6. Nothing else to combine. They're in standard form because a has a degree of 1 and numbers have a degree of 0, and we're just kind of on a countdown. So that's going to be our biggest thing. Whenever I see the minus in the middle, that's going to switch the signs on each of my terms in the set of parentheses following it. So once I get my signs situated, which one of my terms, 3x squared has a degree of 2. So that's going to go first. Any other terms then that still have a degree, so 9x, and then I can combine my constant terms, 2 and 5 is 7, degree of 2, degree of 1, degree of 0, and it just counts down from left to right. And that's going to be my biggest thing going through these with you, is just making sure that if that minus is there, so that becomes negative 6 or minus 6, and negative times negative is a positive 2x. And just like before, I got to take a moment to pause and look and say, okay, where's my largest degree going to be? Well, it's going to be with the ones that have xy. Because xy has a degree of 2. So how many xy's am I going to end up with when I combine my like terms? 3, because I got 9, and it's minus 6. The signs matter. And I'm like, all right, let's see, I'll do my x's next here. Negative 2, negative 2 and positive 2 cancel. I don't have any x's left. So all I got left is this y here. And again, I can't put these together. This has x and y, this only has y. So that's as far as I'm going to be able to go. Sure. It would be the same idea as the up as it being in the middle there. It still would work the exact same way. That's a good question. Yeah, anytime you see a negative in front of a set of parentheses, no matter where that negative is, we need to go ahead and distribute that. So as I come down and start to look at some of these problems a little bit below it, it comes back to the same thing. Always be looking for that symbol in the middle. If it's plus, you can just start combining things that are alike right away. So like here, since it says plus, I can start putting these together. I see xy squareds, Those have a degree of 3, so we'll start with those. 6 and negative 10 would be negative 4 xy squared. And then you say, well, how's the next part going to work? Well, yep, these have x and y, so they'd have a degree of 2, because I'd add those up. But my y squared also has a degree of 2, so the order's not going to matter. So 4xy and 2xy is 6xy. And then y to the second's left there. But these two would be interchangeable. And I'd be set with those. But again, if I get to one like 9, where that negative's there, or that minus sign, I've got to make sure that gets distributed through. So the opposite of negative 3a is positive 3a. The opposite of a positive 5b is a minus or a negative. And all of my terms have the same degree, so it doesn't matter if I start with a or b. Again, combine your terms that are alike. And be real careful on the b's here because they're both negative. So just keep thinking about money. If I owe somebody $8, and then I borrow 5 more, now I owe them 13. And don't even let multiple pluses or minuses get you. Just kind of keep working through them the same way. Now, over on the back, we'll come back here for a minute if we have to momentarily. No, we are not doing the in the book. You can kind of give that the... So back here again, just one last reminder. I want to look at 19 and 21 and then kind of get us rolling here. So here, a few more terms. That first set of parentheses just kind of drops. And I distribute that negative all the way through, switching all of my terms. So which type am I going to be starting with on 19? Yeah, I'm starting with the m squareds because they have the greatest degree. Watch your signs. So 2 minus 4 is negative 2. My m's would come next. And then, yep, 1 and 3 is 4. And if you do get an occasional story type or application problem thrown in, no big deal. Measures of two sides of a triangle is given. If P is the perimeter, and the perimeter equals 10x minus 5y, find the measure of the third side. Okay, so let's see here. Perimeter, what do you do to find the perimeter of something? Add up all the sides. So, what we can do is, we don't know right now anything about this side. But let's add up the other two sides. So if I combine my like terms, I have 8x. Yep, and 4y minus y is plus 3y. But I need to add up to this. So to figure that out, if I take the total and subtract what I have so far, oh, it kind of looks like the problems we've been doing. I can distribute that value through. Change the sign on my 8x, change the sign on my 3y. And carefully combine like terms, watching the signs. 10 minus 8 is 2. 5 minus 3 is 2. And I have my mystery side. Yeah, the only time we're going to change signs is when there's a minus or a negative in there, absolutely. Otherwise, we're just going to leave the signs the same, and then we're going to just start combining them. So again, keep this handy, because in case you forget something sometime or need an example or want to use it on the quiz, you can do that. So the other sheet is the actual assignment that we're doing. And again, watch the signs in the middle. So like for instance, let's say we're doing number 1. Good place to start. I notice the minus. So I start to distribute that through. I don't touch anything in that first set of parentheses unless I happen to see a sign out in front of it. So I'll change the signs on every one of these.
Why do you make 7?
Well, because here, this minus changes the sign on this. So since it was negative before, that minus will change it. It always switches the signs on everything. Because now, once I've distributed that through, now I got to go through and start figuring out what goes first, what goes second. Remember, look for your largest degree, your biggest exponent. So which term's got the biggest exponent? Yeah, negative 6b to the 4th. Okay, I've only got one of those, so I'll kind of cross that out as I use it. Which one would come next? Yeah, my third. So plus 7b to the 3rd. And then, yep, and I notice there's no b squared, so b comes next, but I got 2 of those. So I've got to watch my signs. A positive 3 and a negative 6 is a negative 3b, or if you want to put the 1 on there, you can. Yep, and then finally, a negative 2 plus a positive 8. If I owe somebody $2, I find $8 in my pocket. I'm $6 ahead still. Which is how that part would work. And then I wanted to review a couple of the things from yesterday, either because you got some people that aren't here, or maybe you forget about something. So if we roll down here towards the bottom of this front page, okay, name the polynomial by degree and number of terms. Okay, so let's say we were doing number 10. Okay, first things first, how many terms are there in number 10? Okay, there's 2 terms. So what do we call a polynomial with 2 terms? A binomial. And then my degree would be, what's my biggest exponent? 5. And we're set there. And again, if you forget something about this a little bit, you know, grab that note sheet from yesterday. If you weren't here, they're right in the very front there to kind of get you set with that. Then, easier. On the back, we're going to review exponent rules a little bit and start getting you ready for what we're going to be trying out tomorrow. So when it says find each product, we're going to distribute. We're going to look at 17 and 18. So 17, 6 times 6 is 36. Then I just put the n with it because there's no other n to multiply it by. And 6 times negative 5 is negative 30. Those aren't like terms, so I can't combine anything else. That's as far as I can go. Now 18 is a little bit different. 3 times 7 is 21. What's k times k? Yep, k to the second, because when I do k times k, I add their exponents. So 21k to the second. And then 3 times negative 6 is negative 18, and I don't have another k to multiply by this time. And these are different since this is k to the second, or k squared, and this is just k. So your job is to fight your way through the rest of this sheet, and if you haven't done so yet, to finish off yesterday's and get that one turned in.